And now a brief look at Descartes' methodology. One of the core aspects of his methodology was mathematics. He used this mathematics as a model for his quest for certainty and also in his quest for a universal science. Now the reason for this is because he found the certainty and self-evidence of mathematics to be very appealing, and he believed, perhaps incorrectly, that it could be applied to all questions. Not surprisingly, his view of the method was expressed in his discourse on the method, etc., etc., etc. Now, he broke mathematics down into two mental operations, intuition and deduction. Intuition works like this. It's a recognition of what are taken to be self-evident truths. Truths such that if you understand them, you simply see the truth. Now, what would be some examples of these self-evident truths? Well, for Descartes, they would include the truths of mathematics and the principles of logic. For example, presumably something like that contradictions are always false would be self-evident, or that tautologies are always true would also be self-evident. And as you might recall, a tautology is a claim that is always true in virtue of its logical structure, like, for example, the claim it's raining or it's not raining. A contradiction is one that's always false in virtue of its logical structure, such as today is Tuesday and today is not Tuesday. Now, as he sees it, the way self-evident truths work is this. If you're thinking with clearness and distinctness when examining one of these self-evident truths, you'll simply see the truth, hence it being self-evident. These truths, being self-evident, are not derived from other truths. They're not deduced from them or otherwise acquired from other truths. You simply see the truth. Now, where do these truths come from? Well, for Descartes, he regarded these self-evident ideas to be innate. They're implanted, on his view, by God. Now, we're not always aware of these ideas. Also, rather critically, which in a way harkens back to Plato's view, we can't get these ideas from sense experience. So the self-evident truths are not seen in the sense of like literally seeing them with your eyes or hearing them with your ears. It's just that when you understand them, you sort of mentally see them rather than physically see them. So how do we see them if we're not seeing them with our eyes? Well, what Descartes buys into is something we saw in our good dead friend Plato, the idea of a intellectual vision. It's not sensory, so it's not like your eyes literally. And we saw in Plato the analogy to the eyes, like the soul having an analogical feature to the eyes, and the sun having the being analogous to the good. And so just as in Plato, the light of the sun reveals the physical objects to the physical eyes here in the world, the illumination of the good reveals to the soul through its intellectual vision these truths. And Descartes buys into that notion of an intellectual vision, this capacity to see, not literally see, but to see with this intellectual vision these truths. And this is a common thing in rationalism. And as you might recall, rationalism is the view, put a bit simply, that you can gain knowledge of the world through a priori means. That is to say, through pure reason without having to rely on experience. And an example of this we saw back in the ancient days when he looked at our good dead friend Saint Anselm and his argument for God's existence. So that takes care of intuition. You basically intuit the truths. Now, in regards to deduction, here's how deduction works. This harkens back to our start of the semester when we looked at the notion of deduction. And as you might recall, a deductive argument, if it's doing what it's supposed to, is valid, which means that if all the premises are true, then the conclusion must be true. And as I mentioned back in those ancient days, if you get a deductive argument that's valid, and it really has all true premises, then it guarantees that it has a true conclusion. So you end up with a sound argument. So the idea is that the inferences, deductive inferences, are necessary. So the idea that he wants to take, basically going with our whole deduction, and soundness thing, is he wants to use valid reasoning, in our terminology, using true premises. And these true premises would be self-evident truths. So his view is basically, they'd work like this. You would take self-evident truths, and then from these self-evident truths, which are of course true, you'd use those as premises, and you'd use deductive logic. And if you have a valid argument with true premises, these self-evident premises, obviously you end up with a true conclusion. So his view is you could reach all truths by deduction. So you could sit down, find all these self-evident truths that you can find, put them into valid arguments, and then get to a true conclusion for each argument. Now, he bases this, not surprisingly, on analytic geometry. He was the first person to publish the principles of this geometry in 1637. And the idea was you could take spatial figures, objects in the world we live in, or, could be like, say your smartphone or your car, or even yourself. His view is you can analyze them in terms of numbers and variables. So the physical world could be translated through geometry into mathematical forms. Now, this of course does make a degree of sense, and I'll give two examples of this. One is, consider, say, drawing. If you ever learned how to draw, one of the sort of the basic lessons is taking complex shapes, say like a dog or a cat or a person, and reducing them down to geometric symbols. The head you draw initially as like a circle, and you might draw the arms and as rectangles, the chest also as a rectangle, and then of course you fill in more details, but you can build all these figures and shapes by these simple geometric shapes. Example 2, think about like in video games or computer animation. Initially, of course, they start off with relatively simple shapes, and they put them together, and then they form these complex animations that we see in, high-end video games and animated movies. So it certainly does have an appeal. Now, his view was you could use this method, intuition plus deduction, to apply that to all knowledge, not just geometrically, but also to all knowledge. So to recap, his view is that by combining intuition, where you recognize self-evident truths, you take those self-evident truths that you discover with this intellectual vision, you plug them into deductive arguments, valid ones, and lo and behold, you end up with a true conclusion for each argument, and this enables you to build your knowledge. So if you know it's valid, if you know the premises are true, then you know the conclusion is true. Now the work that he created to present his view, sort of his main work, is of course his most famous Meditations on First Philosophy. He writes them as if he wrote them over the course of 6 days, but in reality he wrote them over about a decade, and they of course are written as if each one is a single day, but again written over the course of 10 years. Why the 6 meditations? Well, it seems likely to be based on the fact that the Jesuits would spend 6 days of Holy Week studying the spiritual meditations of Ignatius Loyola, the founder of their order, hence the 6 meditations. So that brings us to the end of a brief look at his methodology. Next, we'll turn to, in the next badly done video, we'll turn to the first meditation, the method of doubt.